we are going to spend a little bit of time talking about the 4 standards in our adding and subtracting whole numbers and decimals unit. We have 3 that are supporting standards and 1 that's a readiness standard. 5.2c is supporting, 5.3a is supporting, and 5.10f is supporting. 5.3k is our readiness, and you'll see that throughout several units this year. We're going to start with adding and subtracting whole numbers and decimals for 5.3k. So let's first begin with talking about 5.2c and 5.3a. So 5.2c is our rounding teak. So what do we have to round in 5th grade? We have to round to the tenths or hundredths. Round decimals to the tenths or hundredths place. Now, does that mean we're never going to have to round a whole number? No, it doesn't mean that. It means that we are expecting students who have only rounded whole numbers in the past, in the prior grades. In 4th grade they rounded to the whole number. Now they are expected to round numbers to the tenths place or to the hundredths place. So remember, prior grade learning is also expected to carry forward. So those are expectations as well, being able to take a number and round it to, let's say you had $4.53 and you want to round that to the nearest dollar or nearest whole number. That would be acceptable here too. This is the first time students are introduced to rounding numbers to a specific decimal place. So you have to think about that. If I'm going to round to the hundredths place, then I must have a number that goes to the thousandths place in order to round to the hundredths. I'm going to remember that all of my standards filter through my place value requirements. So if students are only expected to work through the thousandths place in 5th grade, then even when I'm asking them to round, I shouldn't give them numbers with places beyond the thousandths place, even if I'm asking them to round to the hundredths. For example, or this would be a non-example, not something we're going to do. If I had the number 43 and 1,625 10,000ths, I would not give this number to students because it does not fit our place value teaks, even if I was asking them to round to the tenths or hundredths. So this is a no-go because it doesn't fit place value teaks. So whatever numbers that I give to students, they have to fit our place value teaks first. Then I'm able to ask them to round to the hundredths place or the tenths place. So an example that I could give them would look like this, 43 and 162 thousandths, and I could ask them here to round to the hundredths place or round to the tenths place, whichever one the question asked. This fits my place value teak, and I'm asking them to round to one of the 2 places that's listed in my standard. Now remember, when I'm working in 5.2c and I'm asking students to round, that follows specific rounding rules for math. So I have to follow rounding rules. Now I'm going to ask you, please don't teach funny little sing-songs and tricks. Follow rounding rules. Teach them the mathematical rules for rounding. Here's why. If a student is introduced to rounding in 3rd grade using that 3rd grade teacher's funny little sing-song to remember how to round, and then they go to 4th grade and they're taught a different little song to remember how to round, that feels like new learning to a student because I didn't connect it to their prior learning. Then I come to 5th grade and I learn my 5th grade teacher's favorite little rounding song. That still feels like new learning again. So instead of capitalizing or leveraging the learning from 3rd grade and 4th grade and activating that prior learning or schema, I'm causing students to feel like I'm learning something new every year when I'm not. I'm building on what I've learned in 3rd grade and 4th grade and 5th grade. So we don't teach tricks or silly little songs. We teach the rounding rules every time. We teach the rounding rules. So if it's 0 to 4, the number stays the same. or the next digit stays the same. If it's 5 or more, the digit rounds up. That's it. I don't have to teach any tricks. I just teach the rules. So if I was going to round 43 and 162 thousandths to the hundredths place, I would look at the thousandths place, and because it's 0 to 4, the hundredths place stays the same. So it's approximately 43 and 16 hundredths. If I was going to round it to the tenths place, push that so you can see it a little bit more. I was going to round it to the tenths place. I'm looking at the digit next to it, or the place value next to it, and I'm saying this is 5 or more, so my digit in the tenths place rounds up. So this is approximately 43 and 2/10. So I'm teaching the rules. Now, 5.3a is similar to rounding, but it's estimation. And estimation is not required to follow specific rounding rules. I'm not required to have a specific place value that I want to round to. I'm not going to be told a specific place value to round to because it's estimation. I want to use what makes sense. For example, if I was at the grocery store and I wanted to figure out about how much my groceries were going to cost, I would want to make sure that I was rounding probably to the nearest dollar. If I was buying something that costs a lot, like let's say I'm at a clothing store, maybe it wouldn't make sense to round to the nearest dollar. Maybe everything was nearly or easily rounded to the tens place. So all the prices were close to a multiple of 10, and it would make sense for me to round to the tens place to keep a running total in my head. So estimation is used for reasonableness. I'm more concerned about the reasonableness of my estimation. I'm definitely missing some reasonableness. I missed some letters in there. I wrote fast while I was talking. Some important things about estimating. If I'm given a list of prices and I'm asked to estimate a total of those, I'm going to round before I solve. So I estimate my prices, then solve. Think about that in a real world setting for a second. If you went to the grocery store and you wanted to know about how much your groceries were going to cost, you wouldn't total them up to the exact price on your calculator and then round that number, because you already know the exact. Why would you need an estimate anymore? You already know the exact total. Students don't know that that doesn't make sense yet because they haven't had experience with that. So they have to be taught that we round the numbers first, or estimate first, and then add or subtract to solve. So that's a rule when you're solving a problem that says about how much would it cost to, or approximately how much do these groceries cost. We round and then we solve. Okay, let's talk about 5.3K. And you might be thinking, why are these together? Why are these standards together? Because we want to build reasonableness in our students every time we're solving a problem. So 5.3K is our standard that is just add and subtract all positive rational numbers. And you're thinking, I haven't had to remember what a rational number is since a long time ago. A rational number just means whole numbers, decimals, or fractions greater than 1. So this is whole numbers and decimals in this unit. We'll get to fractions later on. That's not part of this unit. And these are all positive. We don't deal with negatives in elementary school, so we are not worried about negatives, only positive numbers. We've got enough to work with with just positives. So in 5.3K, in this unit, we are adding and subtracting whole numbers and decimals. And that doesn't mean I'm going to do some days on whole numbers and then some days on decimals. It means I could be adding or subtracting a whole number with a decimal. So that poses some struggles for kids, which is where this reasonableness conversation comes in. If I'm asking students to subtract 53 minus 1 and 649 thousandths, I need to think about reasonableness before I start solving. So I would have that conversation with kids. What is this close to? Well, it's close to 2. What's 53 minus 2? Well, 53 minus 2 is 51. So my answer should be in the ballpark of 51. Is it going to be more than 51 or less than 51? It's going to be more than 51. How do you know? Because this isn't 2, it's less than 2. So I'm really taking less than 2 away from this. So now, the next part that poses problems for kids is knowing how to do a problem that looks like this. I have to remind kids that we line our numbers up by their place value. Now, notice there's a lot of numbers after the decimal in this one, and there's no numbers after the decimal in this one. The biggest misconceptions you will see with kids is they will just bring these numbers down, 9, 4, 6. The answer is 52 and 649 thousandths. But we just talked through that with our reasonableness and said that the answer should be not greater than 52, a little bit less than 52, between 51 and 52. So that helps me already know that that answer can't be right. So just like in our comparing and ordering unit, we have to have kids put the zeros here. Now, that's not going to prevent every student from saying 0 minus 9 is 9, 0 minus 4 is 4, 0 minus 6 is 6. That's still going to happen even in 5th grade, unfortunately. And we have to take time to talk to students about, if I have 0 of something, can I give 9 of that away? And regrouping across a lot of zeros like this is a struggle for students. I have seen kids do so many crazy things when they're faced with this kind of problem. So we talk about in earlier grades shifting. We would shift one whole to here. So this became 10. Why? Because 10 tenths equals one whole. Now I'm going to shift a tenth to here. And so I took one of those away. This now is 9 tenths. I shifted a tenth to here. 10 tenths. Aha. That is still equal. So I'm able to shift 1/100th, or sorry, 10 hundredths equals a tenth. I'm able to shift 1/100th to here. This becomes a 9. Now this is 10 thousandths. So we're staying there and understanding that whole property. Now I can subtract 10 minus 9, 9 minus 4, 9 minus 6, 2 minus 1. Look at that. We expected our number to be a little more than 51. Is this a little more than 51? Yes, it is. I would expect students to then use the inverse operation to check their work and make sure they did it right. This should be an expectation for every problem. They have to check their work. And I know I got it right. This is all going to be done through the lens of problem solving. So those process standards always talk about real world problem solving. You are not going to see naked numbers or pure calculation, pure algorithm given to students and expected to solve at a 5th grade level. It's going to be in a problem solving setting. So we've got to do this we've got to do this in all problems from the very beginning of the unit in a problem-solving setting. We can't teach process and then come back later and try to take time to teach problem-solving. There's not time for that. Okay, and then the last standard in this unit is 510F, which is balance a simple budget. And I know that this is part of the personal financial literacy TEAC strand, but for us it makes perfect sense to balance a simple budget when we're adding and subtracting decimals because we're working with money. Balance a simple budget. So the biggest thing kids have to know for this is in order for a budget to be balanced, income has to equal expenses. If it doesn't equal, then you have to make adjustments. If you have more income than expenses, then you can put some of that income in savings, or you can put that income in an other category for wants beyond your needs. If your expenses exceed your income, you'll learn that is part of 510E. If your expenses are too high, then you have to make choices about what would you do to decrease your expenses. Balancing a simple budget is all about income has to equal expenses, and we do that by adding and subtracting with decimals and whole numbers.